So now, as we know, we started work energy theorem. So as I said, so work energy theorem is only possessed by what? Actually, it is only possessed by the kinetic energy. So now, if I have taken here, just a minute, my power writing part. Yeah. So now, work energy theorem, if it is only applicable for the kinetic energy. So kinetic energy means body. When the body will possess, when the body is in what? Motion. So we all know that when the body is in motion, the energy possessed by the body is kinetic energy. And what is the formula? Half m v square. So now where I think we stopped, I think we are continuing now. Kinetic energy depends on what, everybody? Kinetic energy depends upon frame of reference. The frame of reference in the sense of, so we all will decide that based upon the frame of reference, we can decide that either the body is said to be in motion, or the object is said to be in what? Object or body is said to be in state of rest. Correct? So I think I have given you the definition of state of motion and state of rest. Am I right, guys? Everybody? All of you?
Yes, sir.
Yes. So now let us see, for example, when we can say object is in state of rest or state of motion. So let me consider there is a rail, okay, a train which is passing. So now, this is one. So now this is one person, A, and this is another person, B, and this is another person, C. Okay, everybody? A, B, and C. Now, according to C, so according to C means who is our observer or reference point? Who is our observer as a reference point? C. Okay. So C is in outside the train. Now train is moving. Now tell me with respect to C, A and B are in motion or A and B are the kinetic energy.
Motion.
The kinetic energy of B or A, which is equals to how much? Half m v square. Am I right or wrong? All of you? Now,
Yes, sir.
according to B, what is kinetic energy? According to B, what is the kinetic energy of A? Can you tell me, everybody? What is the kinetic
Zero.
energy? That is what. So according to A, the kinetic energy of according to B, kinetic energy of A is equals to half into m into v square is what? Velocity is 0. So that, what is the answer? Everybody? Zero. Why? Because A and B both are in the same reference. Both are in the same train. So with respect to A, B is in state of rest. With respect to B, A is also in state of rest. But with respect to C, A and B are in what? State of motion or state of rest?
Motion.
State of motion. Understanding? And with respect to AB, C is also in what? With respect to AB,
Motion.
C is also in what?
Motion.
But actually C is in state of rest. But with respect to AB. So based upon the observer's point of view or based upon the reference point, that is what we used to call as reference point, observer's point, or frame of reference, the same object appears to be in state of motion, or the same object appears to be in state of rest. Understanding, all of you? So that is what. But the work energy theorem only possessed when the object is in what, everybody? When the object is in motion. Understanding, all of you? So that is what you have to remember. Only kinetic energy. So what does it mean? Let us understand and make it. So work energy theorem. So definition of work energy theorem. Please keep reading. Work energy theorem, which you studied in 9th class. Same actually. But I don't know how many of you at least you remembered and heard this about this word also. I don't. Okay. So what do you mean by that? Means total work done by all the forces on a body. All the forces means eval forces. Check it, this one. What do you mean by this all? Just now, last lecture we studied. What is that? That is what? It is a conservative. Maybe it is a what?
Non-conservative.
Non-conservative means it is a friction. Conservative means it is a what? A spring force, gravitational force,
Electrostatic.
okay, electrostatic force. Or the conservative forces, we can say either it is the internal forces, or we can say what, everybody? It is the, yes, respond, external forces. Anything it may be. Understand, Rudresva? So any type of forces, the total work done total work done by all the forces on your body is equals to change in kinetic energy. Change in kinetic energy. Change in kinetic energy of the body. That is only called as, what is to called, everybody? Work energy theorem. Okay? All of you, everybody, please respond. So, what is that? The total work done by all the forces acting on your body, maybe it is a conservative forces or non-conservative forces, some other XYZ, it doesn't matter. All of you understand about? So which is equals to change in kinetic energy of the body. So that is only we used to called as work energy theorem. Understanding now? So all of you remember this work done we have studied 3 types. If the work done is positive, forget about the zero work done. If the work done is positive, means kinetic energy also what? Everybody. Kinetic energy is also increases. Understanding? If work done is negative, if the work done is negative, then kinetic energy is what? Everybody. Kinetic energy is decreasing. Okay. So please remember that. Understand that? So work done is positive, kinetic energy is increases. Work done is negative, kinetic energy is what? Decreases or increases? Everybody. It is
Decreases.
decreases. That is what. Okay. Now, so what do you mean by the definition? Everybody read what is that? Total work done by all the forces on your body. Means what forces? Everybody. Work done by conservative forces, work done by non-conservative forces, work done by internal forces, work done by external forces. Everything is equals to what? Everybody. Change in kinetic energy. Am I right or wrong? Everybody, please respond. That is only called as work energy theorem. Any doubt, please respond. All of you. Clear, Mr. Rudreswa? So W by all forces is equals to change in kinetic energy. So change in velocity means I can say final velocity minus initial velocity. Same way. Change in kinetic energy means what will happen? Anybody can tell me? Final
Kinetic energy
Minus initial kinetic.
yes, initial kinetic energy. So that is only called as work done by all the forces on a body. I hope everybody understand. Everybody. Now, for example, the work done by all the forces is extremely small, very, very minute. Then we have to use something. What is that? Mathematics tool, which we already studied. Extremely small. What is that, guys? Differentiation. Understand all of you? So work dW by all forces, which is equals to differentiation of kinetic energy. Am I right? Everybody understand or not? Please respond. All of
Yes,
you.
sir.
So that is what. So we have to prove it now. What is this differentiation of answer? So work energy theorem, we have to prove that this formula. Work done by all the forces is equals to final kinetic energy minus, what is that? Initial
Kinetic energy.
Okay. So 11th class proofs are very important. Okay. So now for 9th class level, I will teach you first and then we'll go to the 11th class. Okay, Rudreswa, Pradosh. For 9th class, we'll say, for example, a body is traveling with initial velocity whose mass is m. Okay. Now, after certain time, after traveling certain distance, his velocity increases to v. So mass is remains constant. So here, what is the kinetic energy? Kinetic, this is Ke1, initial kinetic energy, Ki, and this is final kinetic energy, Kef. So what is the change in kinetic energy? Change in kinetic energy equals to work energy theorem. Clear, Pradosh? Work energy theorem, which is equals to, so change in kinetic energy, final. So final kinetic energy, that is what Ke minus initial kinetic energy. So initial, which is equals to half m v square minus half m u square. So both half and m is common. So with that v square minus u square. This is only called as work energy theorem. Am I right or wrong? Verify it, everybody. Final kinetic energy minus initial kinetic energy. 9th class means that's all simple. Any doubt, anybody? All of you? So 9th class you might be studied. Work energy theorem is equals to, understanding? Change in kinetic energy, which is equals to half mv square minus half mu square. Am I right? Everyone, please speak. That is what it
Yes,
is.
sir.
But what about the 11th class? Is it the same thing is sufficient? No. So here we are studying many things. So as it is very, very extremely small. So we all knows that proof. proof for 11th class. 11th class proofs are very important. Okay. So work done is equals to, is it a constant force or variable force? First you decide that. Either it is a constant force or variable force. Everybody, it is the responder. It is a what forces? Variable forces. So variable forces means integration. Can you respond me, everybody? F dot dx. Am I right or wrong? If it is a variable forces, work done is equals to integration of f dx and limit is x1 to x2. Am I right? Speak, Amma. We have studied or not? First lecture. Yeah, the use
Yes, sir.
simply speaking, always nonsense people. So x1 to x2 limit, F means we all people know Newton's second law. F is equals to what? Ma. So I will replace it Ma into dx. So mass of the bodies remains constant. So it will come like limit x1 to x2 A dx. Am I right, guys? Everybody, please respond.
Yes, sir.
Now, acceleration. So acceleration means what? We all people knows. Acceleration means what? Rate of change of velocity. Is it right, everybody? Rate of change of velocity. This is one formula. Another formula also there. Can you tell me what is another formula for acceleration, Pradosh? I want to see how much you remember. Another formula for acceleration. You just divide with the dx.
Sir, into dx by dx.
Yes, yes. So, if you make it dx by dt is equals to rate of change of,
V.
displacement by time is what? Yeah, dv by dt.
V into dx.
Into
dx.
dx.
Yeah, sorry, dx by dt is equals to v.
ddt is what is.
V dv by dx. Am I right or wrong? Acceleration.
Yes, sir.
Yes, sir.
So m x1 x2 a means I will write v dv divided by dx into dx. So dx cancel or not, everybody? So if entire x function is cancelled, then this limits also will changes. Now the function is there only v dv. Am I right or wrong? V dv. Now differentiation of x gone, then differentiation of v alone present. Then here also limits will changes, not x1 and x2. What is the limits will come? Final,
U to V.
yeah,
V of
initial,
V.
you can put it as initial velocity vi and final velocity vf. Understand this step, everybody? I want
Yes,
to
sir.
as dx
Yes, sir.
the x term is removed, then limits also will changes. That is become final velocity to initial velocity. That's all. So as it m is constant, differential integration of v dv. Integration of v dv. What is that? Check it. Integration of x dx. Integration of x dx is equals to x square by x.
X square by 2.
Same way, integration of v dv is equals to v square
V
by.
square by 2.
Okay,
V square by 2.
v square by 2 limits is what? Initial to final.
Fine.
Okay, that's all. Then 1 by 2 I will bring it outside. So 1 by 2 into m into, so this one v square final minus initial. So that replace it, m into final is how much? Vf. So
Vf
vf
square
minus
minus
initial is
Vi square.
so if I multiply it, it will come it as a what? Half into m vf square minus half into m vi square. So that is only equals to what, everybody? That is only we used to call as what? All of you, work done. That is what we used to call as, what used to say?
Work energy theorem.
Yeah. Work done, work energy theorem. That's all it is. Clear, everybody? Half m final velocity square minus half m initial velocity square. So this is only called as work energy theorem. So this proof is also very important for your DRD exams, school exams and all. They'll ask this only for even 5 marks also. Okay. So this is what about it. Anybody having doubt, you can ask me. From here, numericals and all will continue in the tomorrow's class. Work energy theorem, the most important concept for IIT JEE and as well as NEET. Okay. So formula, I hope it's a very simple concept. That's what I said. Now onwards, the remaining chapters, you are having an idea already in previous classes. Just if you focus it, it will go very faster. Do you understand, Ra? So of course, motion in a plane, motion in a that and also we have idea, but many new concepts. But here and all, many things from 9th class, just at least have a touch. If you are good in basics, definitely it will go very well. Okay. So that's all about the today's class. I hope you all understand. Anybody having any doubt, please let me know, or else you can leave from the meeting. Okay. So have a nice sleep. Get back to the bed immediately, and we'll meet tomorrow. So please wake up morning 5 o'clock, as you don't have any school tomorrow. So please kindly use it for betterment. Work hard and make your preparation better. That's what is the only suggestion. Okay, guys. Good night, everybody. We'll meet in tomorrow's class. Thank you, all of you.
Thank you, sir.
Yeah. Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you. Thank you.